To answer our first question in regard to describing the similarities and differences between the file system structure of Windows operating systems and Linux operating systems, the similarities begin for Windows and Linux. Basically, both organize data into hierarchical file systems with root directories, system folders, user data, and permission models, but they differ significantly in layout conventions, metadata structures, and typical enterprise tooling. From a business perspective, Linux offers advantages in flexibility and cost for server workloads, while Windows can be preferable where tight integration with Microsoft ecosystems and non-technical users is critical. In regard to the Windows structure, they're using particularly drive letters such as like C, Delta, Echo, basically as roots with standard top-level directories like C, /Windows, program files, users, basically for system files, applications, and user profiles respectively. NTFS also maintains a master file table, or MFT, that stores a record and attributes basically for every file and directory, including permissions via access control list or ACLs, timestamps, sometimes the actual data, using journaling for metadata integrity, and so on. Whereas Linux structure, FHS, uses a single root directory, essentially with no drive letters, and all device volumes are mounted somewhere within this tree, such as /home, /MNT, you name it. FHS defines basically standard locations like bin and sbin for essential binaries, etc. for configuration, VAR for variable data, USR for shared read-only executables and libraries, giving consistency across distributions. The key differences when it comes to Windows and Linux in that regard is Windows basically ties paths to drive letters and relies on NTFS's MFT and access control or ACL models, while Linux follows FHS with a unified directory tree and POSIX permissions plus optional ACLs. Windows system files are concentrated under that C Windows drive and related folders, whereas Linux system components are spread across FHS-defined directories, which can improve portability and separation of system, application, and user data. On to our second topic, so business preferences, whether Windows or Linux, basically might work best for you. Reasons to prefer Linux from a business context. Basically, it's often lower licensing costs and strong support for open source stacks, which can reduce total cost of ownership for server and cloud workloads. There's also standardized file system layout and strong CLI tooling, making automation, configuration management, and containerization straightforward for large fleets. Now, on the flip side, reasons to prefer Windows from a business context. You have deep integration with Active Directory, Microsoft 365, and Windows-specific application. Basically, it simplifies identity, policy management, and user support in Microsoft-centric environments, which is predominant across the business world. Familiar GUI, or generated user interfaces for your non-technical users, and common commercial applications with mature third-party management tools can reduce training costs for non-technical staff, again, and support desktop productivity scenarios. To boil it down in conclusion, basically for infrastructure focused on web services, containers, and open source databases, Linux is often preferred due to cost efficiency and operational flexibility. However, for organizations reliant on Windows-only line of business, which is the majority of them, and applications, and tight coupling with Microsoft identity and collaboration tools, Windows may be preferred despite higher licensing fees, because it aligns better with business workflows. Part 2 of our second question here, compare at least 2 storage solutions in an enterprise network. For our comparison, we're going to look at NAS, which is network attached storage, and SAN, which is storage area network. Now, I'll go through different aspects, including access model, best workloads, performance, scalability focus, and cost/complexity. Going through for NAS here, essentially, the access model will be the file level over protocols like SMB, NFS, and appears as a network file share. Now, for the best workloads, we're looking at user file shares, collaboration, backups, and unstructured data. Also for performance for NAS, it's good for many concurrent file users. Performance can vary with load. So if you have a bigger business, you're going to have to basically accommodate that. Scalability focus, basically capacity growth and shared access expansion, so you can expand easily. And then for NAS, basically the cost and complexity, it's generally a lower cost and simpler to deploy and manage. Now, moving on to the other side of the fence, the SAN, or again, the storage area network. For access model, we're looking at block level. It's presented as disks to servers over fiber channel, or ISCSI. The best workloads, basically databases, virtualization, latency sensitive, and transactional systems. For performance, it's more predictable latency and throughput under load for block workloads. Scalability focus, performance isolation and service level guarantees as scale increases. Cost and complexity, higher cost and complexity for SAN, basically justified for mission critical workloads. To boil that down, essentially in an enterprise network, NAS is typically chosen for shared user data and team file repositories where ease of management and cost are prioritized. General. SAN is typically deployed for core business systems such as high transaction databases and large virtualization clusters where predictable performance and high availability directly affect revenue. Now for our final topic, from a Christian perspective, identify the ethical considerations of utilizing storage devices in an information technology system when cost consideration are prevalent. Explain the role ethics would play in your decision-making process. So some Christian ethical considerations about storage. Essentially, one of them could be stewardship and cost. Essentially, Christian ethics emphasize stewardship using resources like money, time, and technology wisely to serve legitimate human needs and God's purpose, rather than pursuing efficiency or savings at any cost. When cost pressures are high, choosing a cheaper storage option that significantly risks data integrity, privacy, and long-term sustainability would conflict with this call to faithful stewardship. Moving on to justice, dignity, and trust, another basically consideration. Essentially, storage devices hold data about people. So decisions that compromise security or reliability can harm employees, customers, and communities, undermining their dignity and trust. An ethical approach basically asks whether a storage decision widens the digital divide, exposes vulnerable data, or primarily benefits the organization at the unjust expense of others. Last and not least, role of ethics in decisions. So ethics can set basically guardrails so that the cost optimization never overrides basic obligations, protecting confidentiality, ensuring integrity and availability, complying with the just laws, and being truthful about risks and compatibilities. From a Christian perspective, this means prioritizing solutions that reasonably safeguard people and honor commitments, even if they cost more, and documenting transparent, risk-based justifications when trade-offs are unavoidable.